Today I wanted to answer a question that I receive a lot in emails, other message forums. And that question is, why do I spend so much time talking about code when software is already available for all this stuff? And what people really want is to be pointed to the right package, shown how to download it, how to start it up, and use it for their robots. Hope you don't mind the change of scenery. I'm actually on vacation with the family. I needed somewhere quiet to go, so I came outside, and I don't know if you can see the pond behind me, but it's a nice place to hang out. So here we are. To answer the question why I spend so much time talking about code, writing code even, when software is available for a lot of these things, is because when you're using other people's software, you are truly limited to what they wanted to do with it. And sometimes you won't even be able to fully exploit the capabilities of their software if you don't understand a little bit about the code behind it. Now I know ROS and ROS 2 even have a lot of packages available and some decent tutorials that you can get a robot up and running to some extent or another. You can probably get remote or teleoperation working fine. You may be able to get some SLAM packages implemented with varying degrees of success and be able to click on points on RViz and the robot will navigate to those. You might even get a waypoint follower working where the robot will move from one waypoint to another within a pre-mapped area. But let's talk about that one thing, waypoint following. It's one thing for a robot to be able to move through a series of waypoints, but the waypoint followers I've been able to find do exactly that and only that. You give them a file of waypoints, the robot will go if the rest of the robot is set up correctly. But you still have to start the robot manually by hand, right? You have to start that launch file or the type ROS run on the command line and set the robot going. What if you want the robot to do autonomous operations? What if you're not home? What if you want it to follow some waypoints at a certain interval to do security checks around a perimeter of outside a house or inside a house? The robot needs to be able to intelligently check some things about its own health. Does it have the battery capacity to carry out following the waypoints? Is there another priority? These things depend a lot on what you want the robot to do. If, like myself, your objectives are to have robots just actually do things autonomously without your intervention or explicit commands at any given moment, then you might need the robot to be able to pull one waypoint from the list at a time. It might need to load up different lists, depending on the various behaviors that it was programmed to do. For that reason, I ended up writing an entire Waypoint server. It's open source, it's available, and I'll be doing tutorials on how to use it, although the documentation is pretty thorough. But this is something I had to write because I couldn't find it. It just didn't exist for download. But now my behavior manager can select from any of the waypoint lists, can request one at a time. It doesn't have to go from one waypoint to the other without stopping to do some other operation. The robot might need to deliver something or take a photo, move an object. And these are things you're going to have to be able to write into your own behavior manager. But let's step back even further. Let's say we're not at the point where we're writing behavior managers, and we do just want to be able to tally up the robot or click points in RViz and just have it navigate one point at a time when you manually command it. And that's great. But to get to that point, you're going to have a much easier time if you understand some of the code and data behind these ROS software packages that we use all the time. I'm sure a number of you use or will use one of the most popular LiDARs because it's very affordable and there's a lot of tutorials and it's been proven. But the RP LiDAR A1, I think the A2 and A3 have the same feature, where when you plug them in, the LiDARs are running all the time. Now, if you leave your robot running 24/7 like I do, that's kind of not okay. So I was able to write into a program to call a service that's provided by the RP LiDAR software to automatically start and stop the motor as needed. I did a similar thing with Velodyne VLP16 Puck, which is a 360-degree 3D LiDAR. It's a very cool thing, but it runs 24/7. We might take our robot out of the lab for operations once or twice a week, but we leave it online all the time so we can run various experiments and do development. And these are things that are going to make your hardware last longer and really help your development process because you don't need somebody physically at the robot to start and stop these sensors. Another LiDAR that might be my new favorite inexpensive 2D LiDAR is the LD19 or LD06. They're pretty much the same thing. And because one of my two LiDARs is mounted on the bottom of my robot that you can see here, the beam actually catches the two caster wheels up front and this electronics box that used to be part of a hoverboard in the back. The software driver for this little LiDAR does have a cut angle, so I'm able to cut out one section of the scan that I don't want reported and misinterpreted, but you can see that I actually need to cut out 3 sections where I'm going to get these hits that are within the robot's footprint Those may or may not be a problem, but I find them annoying at the very least. And sometimes when the beam is skimming the very edge of these obstructions that are within the robot's footprint, it will plot out a little phantom obstacle several feet away, and that messes with navigation. Because I understand that a laser scan is just an array or vector of element, I was able to add 2 little lines in the LiDAR's ROS driver that cuts out my angle as well as the original. It took me just a couple minutes to do, and it has saved me a lot of headache. One other area that my team was simply unable to solve without being able to code was RTK GPS. Normal GPS positioning is only accurate within a couple of meters. If you have a special RTK GPS receiver, you can get atmospheric correction data and send it to the GPS receiver, which can then use that information to provide you position data that is accurate to a couple of centimeters. This is fantastic, as 2 meters is quite a big amount of error. We were able to find something called an NTRIP client, which is where we get our correction data, and we were able to connect to the serial data from the GPS and publish the ROS NavSat driver. The piece that was missing was a ROS node that could send the correction data to the GPS receiver. If we weren't able to write some code, we would be stuck with uncorrected data. We were able to write a very simple node that would send the correction data to the GPS receiver and read the positional data back, so our robot is able to navigate within a couple of centimeters of accuracy. You can do a lot of basic robotics without being able to code, although you may find yourself often frustrated because it's difficult to understand how all the different settings and parameters affect the program if you can't check it out for yourself in the code. Open source documentation is hit or miss. Some of it's good, some of it's pretty spotty. Some of it used to be good, and then changes and improvements were made to the programs, but the documentation hasn't been upgraded. I found parameters that weren't referenced in the documentation at all. So being able to look through some code to see why something is not working as expected can really go a long way. Now, I'm not suggesting you wait to start robotics until you're a master programmer. I'm just saying when you're working with something you don't understand why it's not working as expected, take a look through the code. Go to GitHub, or sometimes download a package directly into your Catkin workspace source folder instead of using sudo apt install, and then you can actually play around with it. Make little changes, see how it helps or doesn't help. Maybe just print out some values to the screen and start to learn how that software works. And definitely get used to looking at message definitions for the different ROS data types. I've been surprised at how often I hear from someone that they want to do robotics, but they don't want to learn how to code. They don't have the time, and they're not really interested. And I never really know how to respond to that. You can download a few things, but when you don't want to learn how to code, and you expect to make a robot that does a lot of autonomous behaviors, like truly a service robot around the home or the yard, you're not going to get very far into your project. Understanding how to code and not being afraid to look at some code that others have written is going to save you so much time and frustration, and even the temptation to quit. So those are my thoughts. That's my answer to why I spend so much time talking to you about the code and how something works rather than download this and type that, the end. I've never been a fan of plug and play tutorials because in my experience, they lead to a lot of frustration. What I like for me and what I try to do for you is show you how something works, how I did it and why I did it the way I did. And with a little bit of work on your end, you can make the program or software work how you need it to. Because my robot's not the same as your robot. So you'll see me explaining a lot in my videos and in Practical Robotics in C++. There's a lot in there you won't see in any other robotics book. And I'll be back hopefully next week with another video, either on using the Waypoint Server and doing some waypoint navigation, or I also want to do a comparison between the ERP LiDAR A1 and the LD19 or LD06. This is a great little LiDAR, and I need to do just a little bit of actual testing and side-by-side comparison, and we'll see which one I end up recommending going forward. So the sun's coming out, and I think I'm going to go back inside. I'm Lloyd Brombach, author of Practical Robotics in C++. Thanks for watching. Give us a thumbs up, a subscribe to stay tuned to my new videos, and I will see you next time.